Welcome to XII International School online classes. In the last lecture, we had discussed about the vector form of Coulomb's law, in which we had studied that the force, that is the electrostatic force of attraction or repulsion, that follows the Newton's third law, that is the force exerted by one charge on the other point charge is equal in magnitude but opposite in direction. That is the topic which we had discussed, that is the vector form of the Coulomb's law. Now in this video we are going to study about the electric field, another very important property of a static charge, that is electric field. Now what is electric field? Let's see. Like suppose if I have a point charge, okay, say a charge plus q, the effect of the charge, the area up to which the effect of this charge can be experienced, the area up to which the effect or the influence of this charge can be experienced, that area is known as its electric field. Okay, once again, the area of the influence of this charge is its field, electric field, the area up to which the influence of this charge can be experienced. That is known as its electric field. Fine. So that is the property, we can say, the when a charge in fact rests, then it shows its presence either by force of attraction or repulsion. Now that presence, the influence of this charge is its field, electric field. Fine. Now electric field, as I said, this is one of the property, we can say, the property of the charge. Okay, but as a physical quantity, we study the electric field strength. Okay, now what is electric field strength? Electric field strength is the force experienced by a test charge, a unit positive test charge, when it enters the field of a source charge, or say enters the field of a charge जिसकी field हमको measure करनी, the field we have to measure. In that field we take that positive charge. Suppose if I have a unit positive test charge at point A and I want to measure the electric field strength of this charge, so I take this charge in the field, or will take it near to the charge. Now the force, the magnitude of force experienced by this charge is called the electric field strength of this charge. That means electric field strength is the force experienced by the unit positive test charge. Fine. Now as I had marked here with this arrows, that means this electric field strength is a vector quantity. Now if it is a vector quantity, then what will be its direction of the electric field strength? Okay, so the direction of the electric field strength depends on the direction of the force in which it is experiencing that force. The charge is experiencing the force. Now suppose this is a positive charge and this is also the positive charge. So the force experienced by this charge at this point, suppose say at the point B, okay, the force experienced will be a repulsive force, that is away from the charge. So the direction of the electric field at point B experienced by this charge, test charge, will be away from the charge. That is the direction of the electrostatic force. Fine. Now in case of, suppose, a positive charge, if I take a negative charge, in that case what will be the direction of the electric field? Again, the direction of the electric field will be towards the source charge. Fine, that is attractive. So electric field strength is a vector quantity. The direction of the electric field strength is the direction of the force experienced by that test charge. Fine. Now let's come to its unit, its SI unit. Now this is force, that is Newton, and this is charge, that is Coulomb. Fine. So Newton per Coulomb is the SI unit of the electric field strength. Fine. Now let's discuss about the dimensional formula of electric field strength. Now force, that is again Newton, that is for the dimensional formula for force will be ml t to the power minus 2, the dimensional formula for force. Fine. That is mass into acceleration. You know that in class 11 we have studied. And Coulomb, fine, that is unit of charge. So charge can be written as ampere into time. I hope you remember that we know that I, that is current, in smaller classes, that in class 11 we have studied, it is the rate of flow of charge, that is q by t. Fine. So q can be written as it. Okay. Now the fundamental unit, that is the current is the fundamental quantity, so its unit will be ampere, and t is time, that is second, so ampere second. From here we can say, so the symbol which we use here, that is T in dimensional analysis, you are studied in class 11. So this is ampere time. Fine. So from here we can get the dimensional formula of electric field strength, that is M L T to the power minus 3 A to the power minus 1. So that is the dimensional formula of electric field strength. Fine. So this is something which the introduction of electric field that I had discussed. So let's revise it. What is electric field? Electric field is the area up to which the influence of a charge can be experienced. That is the electric field of a charge when it is at rest. Fine. The area up to which the influence, the effect of a charge can be experienced. Fine. Then what is electric field strength? Electric field strength is the physical quantity that we can measure it. It is the force experienced by a test charge, a unit positive test charge. That is force per unit charge is the electric field strength. Fine. Then the SI unit of electric field strength, that is Newton per Coulomb, and the dimensional formula for the electric field strength, that is ml t to the power minus 3 a to the power minus 1. That is the dimensional formula for the electric field strength. We'll say the field strength simply. Okay. Now let's see the another topic. Okay. So now we'll see the electric field strength due to a point charge, a single point charge, the magnitude and the direction of the field strength, that is electric field strength due to a single charge. Fine. Now as I said, suppose if we have a positive charge plus q, that is q, the magnitude of the charge is q. Fine. Now I have to find the field strength of this charge at some point, say A, which is r distance away from the source charge. Okay. Now what I will do, I'll keep a test charge, say the unit positive test charge at point, say at point A, where I have to find out the field strength of this charge. Now as we know that the electric field is, now we are calculating the magnitude, so I am not using this bar over there. So electric field is force per unit test charge. Fine. Now we know that this force experienced by this charge is the electrostatic force. The magnitude of this force was given by Coulomb and we had studied in the previous video. So if I put the value, you know that, I hope you remember that the force is 1 upon 4 pi epsilon naught q1 q2 upon the r square. Fine. Now here q1 is plus q and q2 is plus q naught. Okay, so I'll put the value here. So it is 1 upon 4 pi epsilon naught q naught upon r square whole upon q naught. This will. So this is the value of force and this is the charge. So force per unit charge. Fine. So now from here we can say that q will be here. Simple math I am going to do here. So 1 upon 4 pi epsilon naught q naught upon q naught r square. So Q naught is cancelled. So the electric field strength due to a point charge is K Q upon R square, where K is the constant. We know that electrostatic constant value is 1 upon 4 pi epsilon naught. Okay, so this is the expression. Now, what is the importance of this expression? Why I had derived this very small expression for you all? What I want to say is, you can see from this expression that the electric field strength does not depends on the test charge, the magnitude of the test charge, but it depends on the source charge and the distance of the test charge from the source charge. It depends on the medium, but it does not depend on the magnitude of the test charge. Okay, so and basically we used to take the magnitude, the test charge with a very small magnitude, that it does not have its own field. Okay, the magnitude of this is very less as compared to the source charge. Fine. So the electric field strength, the formula for electric field strength due to a point charge, that is kq by r square, or I can say that E is equals to 1 upon 4 pi epsilon naught q upon r square. This is the magnitude of the electric field strength due to a point charge. Okay, and direction, as I had discussed, because this is a positive charge, so direction will be repulsive, that is away from the source charge. Fine. So this is a little bit about the electric field strength. Okay. Now the another topic which is important here, that like we have two types of charges we had discussed, that is negative and positive. Fine. So as they are the source of this electric field, so how this electric field looks like around a positive charge and around a negative charge. Okay, so if I have an electron, say minus q, an electron, a negative charge, then the electric field lines, or say the electric field, will look like this. Okay, and if I have a proton, a plus positive charge, then the field will look like this. Now what we conclude? We conclude that the electric field lines, okay, let me tell you what are field lines also. Basically, electric field lines are the imaginary lines which are used to give the magnitude also. Sometimes we can find out the magnitude of the field, that is we can say the strength, the field lines, if the field lines are more, then the strength of the field is more at that particular point. So they are basically imaginary lines. Okay, now if I have a positive charge, then the field lines, that is electric field, originate from that charge, that is positive charge, and the electric field lines will be terminating towards the negative charge. Okay, that means they originate from a positive charge and they terminate towards the negative charge. Okay, that is the nature of field lines around the individual two charges. Okay, this you had studied in class 10th also. In fact, when you had studied about the magnetic effect of current, in that you had studied about the magnet, bar magnet, which contains dipole. We cannot separate the poles of a magnet. Here, charge can be like it is having monopoles. Like I can have a positive charge and a negative charge, but in magnet, we do not have such property. We cannot separate their poles. Okay, so in charges also we are going to study about dipole in further classes, where they used to ask to draw the magnetic field lines around a dipole, magnetic field lines around a single like monopole, a positive charge or a negative charge. Okay, so in the worksheet, I'm going to give you about this such the questions which are asked related to field lines and related to the field strength. Okay, so this is all in this video. We'll continue this in the coming videos. Okay, thank you.